What if everything we perceive as reality is just one tiny fragment of a much grander, more intricate cosmic puzzle? Picture a vast, shimmering mosaic where each piece represents an entirely separate realm, with its own laws of physics, its own version of time, and its own hidden truths. This isn't science fiction, it's the startling premise of the fractured universe theory, a mind-bending idea that suggests our reality might be stitched together from countless nested dimensions, each one as real and tangible as the world we know. From the ancient philosophers who pondered the nature of existence to the modern physicists probing the edges of quantum mechanics, humanity has always been drawn to the tantalizing possibility that there's more to the universe than meets the eye. Think about the stories and myths that have endured across cultures, tales of parallel worlds, hidden realms, and gateways to other dimensions. These aren't just flights of fancy, they might be echoes of a deeper truth. Scientists today are exploring theories that sound just as fantastical, from the multiverse to higher dimensional spaces, all hinting at the same astonishing idea: that reality is far more complex and layered than we ever imagined. What if the universe isn't a single, unified expanse but a sprawling patchwork of realities, each one folded into the next like an infinite cosmic origami? The implications are staggering. It would mean that every decision, every event, could ripple across these nested realms in ways we can't even begin to fathom. In this journey, we'll dive into the heart of this extraordinary concept, unraveling the science that supports it, the philosophy that grapples with it, and the mysteries that still lie beyond our grasp. We'll explore how cutting-edge physics is pushing the boundaries of what we thought possible, and how ancient wisdom might have glimpsed these truths long before modern technology. By the end, you won't just see the universe differently, you'll question the very fabric of your own existence. So buckle up and open your mind, because we're about to venture into one of the most profound and perplexing ideas ever conceived: the possibility that reality itself is a fractured, ever-shifting tapestry of infinite realms. Long before telescopes peered into the depths of space or particle accelerators probed the subatomic world, ancient civilizations were already wrestling with the idea that reality might be far more layered than it appears. Take the Hindu concept of Loka, for instance, a belief that our world is just one of 14 distinct planes of existence, each with its own inhabitants, laws, and spiritual significance. These realms weren't seen as abstract metaphors, but as tangible layers of a vast, interconnected cosmos. Similarly, Plato's allegory of the cave envisioned humanity as prisoners mistaking shadows on a wall for the full scope of reality, hinting at a deeper, hidden world beyond our perception. These ideas weren't isolated. Indigenous cultures from the Americas to Australia spoke of dreamtime or spirit worlds existing alongside our own, suggesting an intuitive understanding that the universe might be more fragmented and more mysterious than it seems. Fast forward to the 20th century, and science began catching up with these ancient intuitions. Quantum mechanics shattered the illusion of a predictable, solid reality, revealing a subatomic realm where particles flicker in and out of existence, and where observation itself shapes outcomes. Physicists like Hugh Everett proposed the many worlds interpretation, arguing that every quantum decision spawns alternate universes, branching endlessly like an infinite tree. Then came string theory, with its mind-boggling suggestion that our universe might be just one membrane or brain, floating in a higher dimensional space, occasionally colliding with others in cosmic whispers we can't yet decipher. Even the concept of dark matter, that invisible glue holding galaxies together, hints at realms beyond our senses where unseen forces tug at the fabric of reality. What's fascinating is how these modern theories mirror the oldest human questions. The Mayans believed in portals to other worlds. Today, physicists speculate about wormholes. The Norse spoke of Yggdrasil, a tree connecting 9 realms. Now, mathematicians model multiverses with similar complexity. This isn't coincidence, it's a testament to humanity's relentless drive to peel back the layers of existence. Whether through myth or math, we've always sensed that the universe isn't a monolith but a mosaic, and that the truth might lie in the cracks between what we think we know. Quantum mechanics doesn't just challenge our understanding of reality, it shatters it into countless pieces, each one pointing to a universe far stranger than we ever dreamed. At the heart of this revolution is a simple yet baffling truth. Particles at the smallest scales don't behave like solid, predictable objects. Instead, they exist in a haze of probabilities, flickering between states until observed, as if reality itself hesitates until we look. This isn't just theoretical experiments like the double-slit test prove it. Shoot particles at a barrier with 2 openings, and they don't follow one path or the other. They act like waves passing through both simultaneously, as if they're exploring every possible route at once. Only when we measure them do they choose a position, collapsing into a single outcome. But here's the mind-bending question. Where do all those other possibilities go? The many worlds interpretation offers a jaw-dropping answer. Proposed by physicist Hugh Everett in the 1950s, it suggests that every quantum decision doesn't collapse into one outcome, it splits the universe. In one branch, you see the particle go left. In another, it goes right. Both happen, but in separate, parallel realities. Think of it like a cosmic choose-your-own-adventure book where every possible choice plays out, spawning new universes with every quantum flicker. This isn't science fiction. It's a legitimate, if controversial, framework embraced by some of the brightest minds in physics. And if it's true, the implications are staggering. Every moment, every breath, every glance, every decision could be weaving an infinite tapestry of alternate realities, each as real as the one we experience. Now tie this back to the fractured universe theory. If quantum mechanics generates endless branching paths, could these parallel worlds be the nested realms some ancient myths and modern theories describe? Imagine our universe not as a lone bubble but as one thread in an unfathomably vast multiversal fabric. Some threads might resemble ours with slight variations, a world where you took a different job or where dinosaurs never went extinct. Others could be unrecognizable with entirely different laws of physics, dimensions beyond our perception, or forms of life we can't begin to comprehend. This isn't just speculation. The math behind quantum mechanics and cosmic inflation, the rapid expansion of the early universe, hints that such a multiverse might not only be possible but inevitable. Yet the real mystery lies in the gaps between these realms. If they exist, why can't we perceive them? Some theorists suggest these nested realities might vibrate at different frequencies, like radio stations playing simultaneously but tuned to separate channels. Others propose they're hidden in higher dimensions, curled up like tiny, invisible origami, folds in the fabric of space-time. And then there's quantum entanglement, that eerie phenomenon where particles instantly influence each other across vast distances, as if space and time don't apply. Could this spooky action at a distance be a glimpse of connections threading through these fractured realms? What's striking is how these modern theories echo ancient intuitions. The Aboriginal concept of the dream time, Hindu tales of overlapping lokas, even Plato's shadows on the cave wall, all seem to whisper the same idea. Reality is a mosaic, and we're only seeing one tiny piece. Science is now catching up, armed with equations and experiments instead of myths, but the core revelation remains unchanged. The universe isn't a single, static stage. It's a living, breathing, endlessly dividing labyrinth of possibilities, and we're just beginning to map its corridors. String theory doesn't just add a few extra dimensions to our universe, it unravels the very fabric of reality as we know it. Picture this: the world around you, with its three familiar dimensions of space and one of time, might actually be floating within a far grander cosmic architecture, like a single sheet of paper drifting in a vast, multidimensional library. According to string theory, the fundamental building blocks of reality aren't particles but unimaginably tiny, vibrating strings, and for their equations to work, these strings need to dance not in 4 dimensions, but in 10 or even 11. So where are all these extra dimensions hiding? The answer is as elegant as it is bizarre. They could be curled up into spaces so small, so tightly wound, that they are completely invisible to us, like the intricate folds of an origami masterpiece seen from a mile away. But here's where it gets truly mind-bending. If these hidden dimensions exist, they might not just be empty, mathematical abstractions. They could be bustling with their own separate realities, each operating under entirely different physical laws. Imagine a stack of papers where each sheet represents a universe. Some might have gravity 1,000 times stronger, light that moves slower, or even time flowing backward. These realms could be mere millimeters away from us in these curled-up dimensions, yet entirely unreachable, like ghosts passing through walls. This isn't just speculative fantasy. The mathematics of string theory suggests that such brain worlds, short for membranes, could exist, with our entire universe confined to one of these floating sheets, oblivious to the others. What's truly revolutionary is how this idea could solve one of physics' greatest puzzles, unifying all the forces of nature. Gravity, the force that shapes galaxies, is oddly weak compared to the other fundamental forces. But if gravity is leaking into these extra dimensions, diluted across countless hidden realms, that could explain why it feels so faint in our own. It's like trying to hear a whisper in a thunderstorm. The sound isn't gone. It's just spread too thin across spaces we can't perceive. Some theorists even speculate that the Big Bang itself might have been a collision between two of these cosmic brains, a violent meeting of worlds that set our universe into motion. Yet the most tantalizing question remains: if these dimensions are real, could we ever detect them? Experiments like the Large Hadron Collider are searching for clues: tiny particles that might briefly vanish into higher dimensions before reappearing, or microscopic black holes that could wink into existence if enough energy is concentrated in the right way. Even gravitational waves, those ripples in space-time, might carry echoes of hidden dimensions, like a distant drumbeat from a room we can't enter. And if we ever do find proof, it would mean that reality isn't just fractured, it's a symphony of unseen layers, each playing its own part in the grand cosmic melody. This isn't just about rewriting physics textbooks, it's about redefining what it means to exist. For centuries, we've assumed the universe is a stage with fixed rules, but string theory whispers a far stranger truth. We might be living in one act of an infinite dimensional play, with countless other performances unfolding just beyond the curtain. The ancient mystics spoke of hidden realms. Modern science might be on the verge of proving they were right all along. What if everything you see, touch, and experience, every star, every mountain, every fleeting thought, is nothing more than an elaborate cosmic mirage? This is the startling promise of the holographic principle, a theory so radical it turns our understanding of reality inside out. Imagine the universe as a colossal movie screen, projecting the illusion of depth, texture, and motion, while the real film exists as nothing but flickering codes etched onto a flat, two-dimensional surface. It sounds like science fiction, but this idea emerges from one of the most enigmatic objects in nature, black holes. When physicists like Gerard T. Hooft and Leonard Susskind studied these gravitational monsters, they stumbled upon a paradox. Black holes swallow information irrevocably, yet quantum mechanics insists information can never be truly destroyed. The solution: maybe the information isn't lost, it's just encoded on the black hole's event horizon, the invisible boundary where light can no longer escape. Like a cosmic hard drive, every particle falling in leaves a pixel of data stamped onto this two-dimensional surface, preserving the universe's deepest secrets in a form we can't yet read. Now, stretch this idea to the entire cosmos. If a black hole's interior can be described entirely by information on its surface, could our universe, a far grander structure, also be a projection from some distant, flat boundary? Think of it like a hologram on your credit card. Tilt it, and a three-dimensional eagle seems to soar, yet the real image is just microscopic grooves on plastic. The holographic principle suggests reality might work the same way. All the richness of our four-dimensional world, the swirling galaxies, the beating hearts, the scent of rain, could be nothing more than shadows cast by data dancing on the edge of existence. This isn't just philosophy. The math checks out. Physicists have found that the equations describing events inside a volume of space can be perfectly mirrored by equations on that space's outer surface, as if the universe is performing an unimaginably complex mathematical trick. But here's where it ties back to the fractured universe. If reality is a hologram, then those nested realms we've been exploring might not be separate at all. They could be different layers of the same cosmic code. Picture a Russian nesting doll where each layer appears distinct, but all are carved from a single block. Similarly, the holographic principle hints that our universe's apparent fractures, parallel worlds, hidden dimensions, quantum branches, might just be different expressions of a unified, underlying data structure. Even time, that relentless arrow we can't escape, might be an emergent property, like the illusion of movement in a flipbook. What's truly dizzying is how this mirrors ancient spiritual ideas. Hindu cosmology describes the universe as Maya, an illusion veiling the true nature of existence. Plato's cave dwellers mistook shadows for substance. Now, cutting-edge physics whispers that they might have been onto something profound. The holographic principle doesn't just challenge our perception of space, it redefines what real means. If the universe is a projection, who or what is holding the projector? Could the fractured realms we've imagined be glitches in the code, or intentional features of a design we're only beginning to decipher? The line between science and metaphysics blurs, leaving us with a humbling thought. Perhaps the greatest cosmic mystery isn't out there in the stars, but in the very nature of our perception. Experiments are already hunting for proof. Gravity wave detectors might find anomalies suggesting space-time is pixelated at the tiniest scales, like a digital image revealing its true resolution when zoomed in too far. Others are searching for thermal fingerprints in the cosmic microwave background, echoes of the Big Bang that could carry imprints of a two-dimensional past. If they succeed, it would mean the universe isn't just fractured, it's a masterpiece of cosmic origami, folded from a reality we're only beginning to imagine. Black holes have long been painted as the ultimate cosmic villains, ravenous voids from which not even light can escape. But what if we've misunderstood their role in the universe? Instead of being mere destroyers, these gravitational giants might serve as cosmic gatekeepers, bridging the gap between our reality and realms beyond. Picture a black hole not as a dead end, but as a tunnel's entrance, its crushing gravity warping space-time so severely that it punches a hole straight through to somewhere else. This isn't just wild speculation. The equations of general relativity allow for such possibilities, suggesting that at the heart of a black hole, the singularity, a point of infinite density, might tear the fabric of spacetime itself, creating a passage to another universe or dimension. One tantalizing idea is that black holes could connect to their theoretical opposites, white holes. Imagine a white hole as a black hole running in reverse, spewing out matter and energy instead of swallowing it. If a black hole's tunnel leads to a white hole in another universe, it would mean every collapse here could birth a new cosmos elsewhere, like a celestial game of cosmic ping-pong. Some models even suggest our own Big Bang might have been the eruption of a white hole in some higher dimensional reality, turning the birth of our universe into the aftershock of another's death. It's a dizzying thought that every black hole might be a one-way ticket to a reality with entirely different laws, where time flows backward or gravity pushes instead of pulls. But how could anything survive such a journey? The tidal forces near a singularity are so extreme they'd stretch any object into a noodle of atoms, a process physicists cheerfully call spaghettification. Yet some theories propose that certain black holes, particularly those that are large and rotating, might offer a gentler ride. Their singularities could form orderly rings rather than chaotic points, creating a stable vortex through which matter, or even an intrepid traveler, might pass unharmed. Of course, this assumes the other side isn't just another crushing gravitational trap, and even if the passage is survivable, there's no guarantee you could ever report back. The laws of physics as we know them might unravel entirely in these bridged realms, leaving no way to send signals home. Perhaps the most mind-bending possibility is that black holes don't just connect universes, they might create them. The holographic principle suggests that all the information swallowed by a black hole gets imprinted on its event horizon, like a cosmic fingerprint. If that data can encode an entire universe, then every black hole might contain a fledgling reality within it, hidden behind its inky veil. Our universe could itself be the interior of a black hole in some higher dimensional space, with every star-devouring behemoth we observe birthing new cosmic offspring ad infinitum. This would make black holes the stitches in the quilt of existence, weaving together a fractal tapestry of nested realities, each with its own black holes spawning yet more layers. The irony is striking. These objects, once thought to be the end of everything, might instead be the crucibles of creation, the hidden architects of the multiverse. From ancient myths of underworld passages to modern physics' wildest equations, the idea persists. Reality is far more connected than it appears. Black holes might not just be tearing space-time apart, they could be holding it together, one cosmic thread at a time. What if the world around us, the warmth of sunlight, the taste of coffee, even the ache in your muscles after a long day, isn't real at all, but an impossibly detailed simulation running on some unfathomably advanced computer? This is the spine-tingling premise of simulation theory, an idea that's gained startling traction among philosophers and scientists alike. At its core, the theory suggests our universe might be nothing more than lines of code in a cosmic program, crafted by beings so advanced their technology blurs the line between creator and deity. But here's where it gets even wilder. If those beings are themselves living in a simulation created by yet another layer of programmers, reality could be an infinite stack of nested realms, each one unaware it's just a subroutine in a grander design. Nick Bostrom's seminal paper laid out the chilling logic behind this idea. If any civilization ever reaches a level where it can run ancestor simulations, hyper-realistic recreations of its own history, then statistically, the odds tilt heavily toward us being inside one of those simulations rather than the original universe. Think of it like this: if there's only one base reality but billions of simulated ones, the chance we're in the real world shrinks to near zero. It's like realizing you're almost certainly a background character in someone else's story, not the protagonist of your own. And if simulations can create their own simulations, the layers could stretch endlessly, a fractal hall of mirrors reflecting realities within realities. But is there any actual evidence? Some point to the odd glitches and inconsistencies in our universe, the way particles at the quantum level behave like pixels rendering only when observed, or the eerie feeling of déjà vu, as if the system briefly buffered. Even the speed of light, that universal speed limit, could be seen as a processing constraint, a way to prevent the simulation from overloading. Then there's the Mandela Effect, where large groups misremember events identically. Could these be patches or updates rolled out across the simulation? Skeptics counter that these phenomena have mundane explanations, but the tantalizing possibility remains. What if the universe's fractures aren't bugs, but intentional seams between nested layers? The implications are staggering. If we're in a simulation, the laws of physics might not be fundamental truths, but arbitrary rules coded by the programmers. Dark matter could be placeholder data, black holes memory sinks, and if consciousness is just an emergent property of the code, death might be less an ending and more a logout screen. Some theorists even suggest we could one day hack the simulation, bending reality to our will, though whether the admins would allow that is another question. Yet the most profound question isn't whether we're in a simulation, but what it means for our search for meaning. If reality is layered, does that make our joys and sorrows less real? Or does it deepen their significance, knowing that every simulated emotion, every pixelated sunset, is part of a grand, perhaps unfathomable design? Ancient mystics spoke of the world as illusion. Modern code might just call it a rendering. Either way, the universe just got a lot stranger and a lot more interesting. We experience time as a river always flowing in one direction, carrying us from past to future. But what if that's just an illusion? Imagine time not as a current, but as a vast, frozen landscape where every moment, your first breath, the fall of Rome, the heat-death of the universe exists simultaneously, like frames in a cosmic film reel. This is the block universe theory, a radical idea that upends everything we think we know about time's arrow. In this view, the past isn't gone and the future isn't unwritten. They're just coordinates in a four-dimensional tapestry, with now being nothing more than where your consciousness happens to be scrolling. Think of it like a DVD. The entire movie exists on the disc from start to finish, but your player only lights up one scene at a time. Similarly, the block universe suggests reality is already complete, and our sense of time's passage is just the spotlight of our awareness moving through it. This isn't just philosophical musing. Einstein's theory of relativity supports it. When he linked space and time into a single fabric, he showed that two events can appear simultaneous or sequential depending on the observer's motion, as if time itself is flexible. GPS satellites even account for this, adjusting their clocks because time ticks slower for them in orbit than on Earth. If time can stretch and warp, maybe it's not flowing at all. Maybe we are. Now take this further. If every moment exists eternally in the block universe, could each one be its own self-contained realm? Picture time as a stack of infinite photographs, each capturing the universe in a single, frozen configuration. In one slice, dinosaurs roam. In another, cities rise. None of these moments cause the next. They just are, like pages in a book where every chapter is written at once. This challenges our deepest intuitions about cause and effect. If the future is already out there, waiting, does free will even exist? Or are we just characters following a script we can't see? Some physicists propose an even stranger twist. That time might be granular at the smallest scales, like sand trickling through an hourglass. Just as a movie appears smooth but is actually a series of still images flashing by, time itself could be pixelated, with each chronon, a hypothetical quantum of time marking a discrete jump between states. This would mean reality isn't continuous but updates in tiny, indivisible ticks, like a cosmic computer processing the universe frame by frame. If true, the smooth flow we perceive is just an approximation, hiding a deeper, fractured structure beneath. The implications ripple into metaphysics. Ancient Buddhist teachings describe reality as a series of fleeting dharmas, momentary events with no enduring self, eerily mirroring the idea of time as fragmented instants. Meanwhile, modern quantum gravity theories struggle to reconcile time's role at the smallest scales, with some suggesting it might emerge from something more fundamental, like a network of relationships between events. Could time be less a dimension and more a side effect of how we stitch reality together? Here's where it gets personal. If time is a block, then your life, every joy, every regret, is already etched into the universe's structure. This doesn't have to feel imprisoning. Think of it like a song. The notes are fixed, but the music still moves you. Whether time flows or just is, the experience of being alive remains vivid, urgent, and yours. The mystery isn't just how time works, it's why we feel it so deeply, even as science unravels its seams. From the moment Neo took the red pill in the Matrix, audiences worldwide were gripped by a haunting question. What if reality isn't what it seems? That iconic moment didn't just launch a blockbuster franchise. It tapped into a fascination with parallel worlds that has fueled storytelling for centuries. But pop culture's obsession with nested realities isn't just escapism. These tales often weave in threads of real scientific speculation, turning screenplays into unexpected mirrors of quantum theory and cosmology. Take Stranger Things and its eerie Upside Down, a shadowy reflection of our world with distorted physics and lurking horrors. It's a perfect metaphor for the multiverse, a hidden layer of existence, vibrating just out of phase with our own, much like the brain worlds of string theory. Even older stories foreshadowed modern physics. Alice's Adventures in Wonderland isn't just a whimsical children's tale. It's a journey through a reality where logic unravels, time behaves strangely, and dimensions fold like paper. Sound familiar? It's not so different from the warped spacetime near a black hole or the quantum foam where particles blink in and out of existence. Then there's the Twilight Zone, where ordinary people stumble into pockets of reality where the rules have shifted. One episode, The Parallel, even features an astronaut who returns to an Earth almost identical to his own, except for subtle, unsettling differences. It's a chilling dramatization of the many worlds interpretation, where every choice spawns a new universe. What's fascinating is how often fiction anticipates science. Star Trek introduced the idea of parallel universes colliding long before physicists seriously considered brain collisions as a possible trigger for the Big Bang. Rick and Morty turns quantum suicide theory into dark comedy, with its infinite Ricks hopping across realities where they either succeed or die in every possible scenario. Even Doctor Who's Time Lords, who perceive all of time at once, echo the block universe theory where past, present, and future exist simultaneously. These stories don't just entertain, they prime us to grapple with concepts that might otherwise feel too abstract to comprehend. But pop culture's greatest gift might be its ability to humanize these mind-bending ideas. When Everything Everywhere All at Once depicts a woman accessing the skills and memories of her alternate selves, it's not just a visual spectacle, it's a poignant exploration of regret, identity, and the roads not taken. The film's chaotic multiverse jumps mirror the probabilistic nature of quantum mechanics, while its emotional core reminds us that even in an infinite cosmos, our choices still matter. Similarly, Interstellar uses wormholes and time dilation not just as plot devices, but as metaphors for love and connection stretching across dimensions. Of course, not all portrayals are scientifically rigorous. Sliding Doors reduces parallel worlds to a simple "what if" about missing a train and Spider-Man. Into the Spider-Verse plays fast and loose with dimensional physics for the sake of spectacle. But even these stories serve a purpose. They make the multiverse feel personal, relatable. After all, who hasn't wondered how their life might have unfolded with one different decision? That's the real magic of these narratives. They take the universe's deepest mysteries and wrap them in stories about people like us, fumbling through a reality far stranger than we ever imagined. The next time you watch a character step through a portal or wake up in an alternate timeline, remember, you're not just seeing fantasy, you're witnessing humanity's oldest questions dressed in new clothes. Are we alone in the cosmos? Is reality solid or shifting? And if we could peer beyond the veil, would we even recognize what we find? These stories don't just entertain, they keep us curious, pushing science to chase the impossible ideas that art dreams up first. The Big Bang wasn't necessarily the beginning, it might have just been our beginning. Picture an endless ocean of energy, seething and bubbling like a cosmic cauldron, where new universes constantly inflate into existence like soap bubbles forming in a froth. This is the mind-bending premise of eternal inflation, a theory that reshapes not just our origin story but the very fabric of reality. According to this idea, the rapid expansion that jump-started our universe, cosmic inflation, never truly stopped. Instead, it's still happening in distant regions of space, spawning an infinite cascade of bubble universes, each with its own unique physics, its own history, and perhaps even its own versions of stars, planets, and life. The clues to this staggering possibility lie in the afterglow of the Big Bang itself, the cosmic microwave background, or CMB. This faint radiation, bathing the universe in a whisper of heat, is like a snapshot of the cosmos in its infancy. But when scientists studied it in detail, they found something peculiar: tiny temperature fluctuations, uneven patches of hot and cold that shouldn't exist if the early universe had been perfectly smooth. These irregularities fit perfectly with inflation theory, which predicts quantum jitters during that explosive expansion would leave wrinkles in space-time. But here's where it gets wild. If inflation is eternal, those wrinkles might not just be random noise, they could be scars from collisions with other bubble universes, cosmic bruises from realms entirely alien to our own. Imagine two bubbles expanding in a foam. When they touch, their walls ripple, leaving an imprint. If our universe collided with another in that primordial froth, the shockwave might have left a signature in the CMB, a strange, circular pattern that defies conventional explanation. Some researchers have even claimed to spot these anomalies, though the evidence remains hotly debated. But if confirmed, it would mean we're not just mapping the birth of our universe, we're glimpsing its neighbors. What's even more staggering is what these bubble universes could contain. In eternal inflation, each bubble is a self-contained cosmos with its own laws of physics. Some might have stronger gravity, making stars burn out in seconds. Others could lack electromagnetism, leaving matter formless and dark. A few might even have extra dimensions unfurled like wings, permitting phenomena we can't begin to fathom. This isn't just speculation, it's a direct consequence of how inflation works. Quantum fluctuations during expansion could freeze into place, locking in different physical constants for each newborn universe. The result, a multiverse so diverse, our reality might be just one mundane variation in an infinite ensemble of possibilities. The implications for the fractured universe hypothesis are profound. If eternal inflation is real, then the cracks between realms aren't just theoretical. They're physical boundaries, the walls of our cosmic bubble, and beyond them. A fractal sprawl of universes, each a closed ecosystem of existence, utterly isolated yet born from the same seething quantum foam. Some might be barren, their physics too hostile for complexity. Others could harbor civilizations asking the same questions we are, staring at their own CMB and wondering if they're alone. Yet the most humbling thought is this: if bubbles keep forming eternally, then somewhere, right now, a new universe is being born. Its Big Bang isn't in our past. It's happening in a now we can never see, in a place we can never reach. Our entire cosmos, with its billions of galaxies, might just be a fleeting eddy in an endless sea of creation, one fragment in a mosaic still being woven. The fractured universe isn't just a theory, it could be the ultimate cosmic reality. Dark matter isn't just a missing piece of the cosmic puzzle, it might be the first tangible clue that we're surrounded by hidden realms, invisible layers of reality brushing against our own. Think of it like this: galaxies spin so fast they should fly apart, yet something unseen grips them together with gravitational fingers. That something is dark matter, a substance that outweighs normal matter 5-to-1 but refuses to interact with light, leaving it utterly transparent to our telescopes. For decades, scientists have chased this ghostly presence. But what if the reason it's so elusive is because it doesn't entirely belong to our universe? Some theories suggest dark matter particles could be visitors from a neighboring dimension, slipping through microscopic cracks in space-time like whispers through a wall. Consider the way shadows move across a curtain, distorted, faint, but undeniably real. Dark matter might behave similarly, existing primarily in a parallel reality where gravity leaks into our world, warping the motion of stars without ever fully revealing itself. This idea isn't just speculative. Certain models in theoretical physics, like the mirror matter hypothesis, propose that every particle we know could have a hidden twin in a shadow universe, identical in mass but blind to our forces like electromagnetism. These twins would pass through us unnoticed, only making their presence felt through their collective gravity. It's as if our universe is one side of a double-sided tapestry, woven together by threads we can't see. The evidence for this grows stranger when you examine cosmic anomalies. Take the Bullet Cluster, where two galaxies collided, and their dark matter, detected only by its gravitational lensing effect, seemed to glide ahead of the visible wreckage like a specter untouched by the chaos. If dark matter were merely a strange form of ordinary matter, it should have lagged behind, slowed by friction. Instead, it acted as if it occupied a separate layer of reality, barely grazing our own. Then there's the eerie alignment of certain dwarf galaxies, orbiting their hosts in razor-thin planes rather than the expected chaotic sprawl. Simulations suggest this could happen if dark matter flows along invisible, cosmic filaments from another dimension, guiding structures into place like unseen puppet strings. What's truly tantalizing is how this ties into the search for extra dimensions. String theory's higher dimensional spaces could provide the perfect hiding spots for dark matter particles, curled up in geometries too small for us to probe. In some scenarios, gravity, the weakest of the fundamental forces, might actually be diluted because it's spreading into these extra dimensions, while dark matter's gravity feels stronger because it's confined to our brain. It's like comparing a shout in an open field to one in a narrow hallway, the same energy, but concentrated differently. Experiments like the Large Hadron Collider are hunting for signs of these hidden dimensions, hoping to catch a glimpse of particles vanishing momentarily into the cosmic substrate before reappearing, leaving behind trails of missing energy. But the most profound implication isn't just about dark matter. It's about what it means for the nature of reality. If dark matter truly belongs to another realm, then the universe isn't just fractured. It's porous, with hidden layers bleeding into one another in ways we're only beginning to sense. Ancient cultures spoke of spirit worlds overlapping our own. Modern physics might be uncovering the mechanisms behind those legends. Every galaxy, every star, even our own planet could be awash in particles from a reality we'll never see directly, bound to us by gravity's silent hand. The cosmos just grew infinitely richer and infinitely stranger. Have you ever been absolutely certain about a memory only to discover the world insists it never happened that way? This unsettling phenomenon is called the Mandela Effect, named after countless people who vividly remembered Nelson Mandela dying in prison during the 1980s, despite him actually passing away in 2013. What makes these collective false memories so eerie isn't just their persistence, it's how specific they are. Millions recall the Berenstain Bears being spelled Berenstein, or the Monopoly man sporting a monocle he never had. Skeptics dismiss these as simple mix-ups, but when so many unrelated people share identical mistakes, it raises a spine-tingling question. Could these be more than faulty neurons? Could they be glimpses of other timelines bleeding into our own? The human brain is a masterful storyteller, filling gaps and reshaping memories to fit narratives we find comfortable. Psychologists call this confabulation a harmless glitch in our mental software, but the Mandela Effect often involves details too trivial to warrant collective confabulation. Why would thousands independently misremember the fruit of the Loom logo featuring a cornucopia that never existed? One theory suggests these anomalies arise from quantum fluctuations, tiny ripples in reality where alternate versions of events briefly overlap. In a fractured universe where countless parallel realities branch with every decision, perhaps our consciousness occasionally brushes against neighboring timelines, borrowing fragments of memories that don't belong to us. It's like tuning a radio and catching snippets from another station before the signal corrects itself. Then there's the simulation argument. If our universe is a programmed construct, the Mandela Effect might represent patches or updates altering shared data. Think of a video game where developers tweak a character's design. Players who noticed the old version could be told they're misremembering. Similarly, if the architects of our simulated reality adjusted details like movie quotes or brand logos, the changes might leave residual memories in some users. Even stranger, some researchers propose that large groups remembering the same alternate past could indicate localized server splits, where subsets of the simulation briefly diverged before reintegrating, leaving conflicting data in their wake. But before we leap to cosmic conclusions, there's a humbler explanation: the power of suggestion. Human memory is highly malleable. Once an idea like the Monopoly man had a monocle is seeded perhaps through a meme or pop culture parody, it can rewrite our recollections en masse. Social reinforcement does the rest, creating a false consensus. This doesn't fully explain cases where people recall the wrong version before ever encountering the Mandela Effect community, though. Some neurologists suggest these glitches might stem from the way our brains store similar concepts in overlapping neural networks, causing details to blur between related images or phrases over time. The truth might lie somewhere in between. Quantum physics allows for the possibility of alternate timelines, while psychology confirms our minds are far from perfect recorders. Whether the Mandela Effect is proof of a fractured universe or just a quirk of cognition, it undeniably reveals something profound. reality isn't just what happens, it's what we collectively agree upon. And sometimes that agreement fractures, leaving us to wonder if the past is as solid as we thought, or if it shifts like sand beneath our feet. Witnesses describe floating above their own bodies, drawn toward a brilliant light at the end of a tunnel, or embraced by long-lost loved ones in a realm beyond pain. Near-death experiences, or NDE, are among the most mystifying phenomena reported across cultures and centuries. Vivid, life-altering episodes that defy conventional explanation. While skeptics dismiss them as hallucinations triggered by a dying brain, those who have lived through them often return, insisting they've glimpsed something far more profound, a hidden layer of reality, vibrating just beyond the veil of our senses. Science offers compelling physiological theories: oxygen deprivation, surging neurotransmitters like DMT, or the brain's last desperate attempt to make sense of its own shutdown could explain the bright lights, out-of-body sensations, and surreal narratives. Yet this doesn't account for the eerie consistencies in NDE accounts. Worldwide details like encountering a life review, crossing thresholds, or meeting beings radiating unconditional love. Even more baffling are cases where clinically dead patients accurately describe events that occurred in other rooms or while their brains showed no measurable activity, as if consciousness had momentarily stepped outside the body's confines. Could these experiences be fleeting visits to the nested realms we've been exploring? Some researchers propose that NDEs might involve quantum processes, the brain's microtubules, tiny structures within neurons, potentially maintaining coherence even after clinical death, allowing consciousness to briefly interface with other dimensions. It's a controversial idea, but if true, it would mean that afterlife isn't a distant heaven or hell, but an adjacent reality, normally invisible until the filters of our biology momentarily lift. Spiritual traditions have long embraced this possibility. Tibetan Buddhists speak of the bardo, an intermediate state where souls wander dreamlike landscapes before rebirth. The ancient Egyptians mapped the Juwat, a realm of trials and transformations navigated after death. Even modern mediums and mystics describe similar, in-between spaces populated by guides and bathed in frequencies our ordinary senses can't perceive. These parallels suggest NDEs might not be random hallucinations but encounters with a deeper architecture of existence, one where death isn't an end, but a transition between layers of a far grander cosmos. Perhaps the most poignant question isn't whether these realms are real in a physical sense, but what they reveal about consciousness itself. If the mind can experience vivid, coherent worlds without a functioning brain, does that mean awareness isn't produced by neurons, but merely filtered through them? Like radio receivers tuning into signals, could our bodies be temporary vessels for something far more expansive? The stories of those who have returned, often with vanished fears of death and renewed purpose, hint that these experiences, whatever their origin, touch something fundamental about the universe's design. Whether NDEs are glimpses of nested dimensions or the brain's final masterpiece, they remind us that reality, in its fullest form, might be far stranger than we dare to believe. Quantum entanglement is one of the most baffling phenomena in physics, a cosmic magic trick where two particles, no matter how far apart, remain mysteriously linked. Change the spin of one electron here on Earth, and its entangled partner light years away instantly mirrors that change, as if space and time don't apply. Einstein famously called this spooky action at a distance, dismissing it as an absurdity. Yet experiment after experiment confirms it's real, leaving scientists grappling with a profound question. How can particles communicate faster than light, seemingly breaking the universe's speed limit? The answer might lie in the very fabric of reality itself, not as we see it, but as something far more intricate, imagine two ends of a single piece of paper. From our three-dimensional perspective, they're separate points, but fold that paper through a higher dimension, and those points touch effortlessly. This is the essence of non-locality, the idea that entangled particles aren't truly separate but connected through hidden layers of existence. In a fractured universe where dimensions are folded like origami, what we perceive as vast distances might be illusory. The particles could be whispering to each other through shortcuts in spacetime, their bond maintained by a reality we can't yet perceive. Some theories take this further, suggesting entanglement isn't just a quirk of quantum mechanics, but the glue holding the multiverse together. Think of it like a cosmic internet, where every particle is a node linked across countless realms. When entanglement occurs, it might not just bridge space, it could bridge realities, threading through higher dimensions to connect versions of the same particle in parallel worlds. This would mean the spooky action isn't action at all, but a reflection of a deeper unity, where separation is an illusion born from our limited perspective. The implications are staggering. If entanglement weaves through nested dimensions, it could explain why quantum particles seem to know each other's states instantly. They're not sending signals, they're different facets of the same underlying structure. This idea finds echoes in holographic theory, where the entire universe is encoded on its boundary, and every part contains the whole. Entangled particles might be like pixels on opposite sides of a hologram, seemingly distant but fundamentally one. Experiments are already probing these wild possibilities. Scientists have entangled particles across record distances, even sending quantum information via satellites, as if testing the seams of reality for hidden threads. Others are exploring whether entanglement can persist through time, linking particles across moments as well as space. If true, it would mean the universe's fractures aren't just spatial, they're temporal, with past, present, and future entangled in a dance we're only beginning to decipher. Perhaps the most poetic thought is this: entanglement might be the universe's way of reminding us that nothing is ever truly separate. From the tiniest particles to the grandest galaxies, everything is interconnected, whispering secrets through dimensions we're just learning to imagine. The spookiness isn't in the action, it's in realizing how much of reality remains hidden, waiting to be unfolded. What if consciousness isn't just a passenger in the universe? What if it's the architect? This radical idea turns our understanding of reality inside out, suggesting that the mind doesn't merely observe the world but actively participates in its creation. At the heart of this mystery is a simple yet profound question: does the universe exist because we perceive it, or do we perceive it because it exists? Some of the greatest thinkers in history, from ancient Eastern philosophers to modern quantum physicists, have grappled with this enigma, and their answers point to a cosmos far more interconnected than we ever imagined. Take the double-slit experiment, one of the most famous puzzles in quantum mechanics. When scientists fire particles at a barrier with two slits, the particles behave like waves, creating an interference pattern on the other side, unless someone observes them. The moment a detector is turned on, the particles choose a single path, collapsing into definite positions. It's as if reality hesitates until a conscious mind looks, then snaps into focus. This phenomenon, known as the observer effect, has led some to propose that consciousness isn't just witnessing the universe, it's completing it. Without observation, the world might remain a blur of probabilities, a fog of unrealized potential. This idea finds its boldest expression in panpsychism, the view that consciousness isn't a rare byproduct of complex brains, but a fundamental feature of reality itself. In this framework, even atoms and particles might possess a rudimentary form of awareness, like faint sparks in a cosmic mind. If true, then the universe isn't a cold, mechanical machine but a vast, shimmering network of experience, where every star, every rock, every quark hums with some degree of inner life. The implications are staggering. It would mean that nested realms, alternate dimensions, or parallel universes aren't just out there, they might be shaped, at least in part, by the collective consciousness that perceives them. But how could something as intangible as a thought influence the fabric of reality? Some theories point to the quantum vacuum, the seething sea of energy at the smallest scales of existence. If consciousness interacts with this quantum substrate, it might act like a sculptor, molding possibilities into actualities. Think of it like tuning a radio. The stations are all broadcasting, but you only hear the one you select. Similarly, our focused awareness could tune in to specific versions of reality, collapsing infinite potentials into the single world we experience. This doesn't mean we can manifest anything with our thoughts. Physics still has rules, but it hints that the line between observer and observed might be far blurrier than we assumed. Ancient wisdom traditions have long embraced this interconnected view. Hindu scriptures describe Brahman, the ultimate reality, as a cosmic consciousness dreaming the universe into being. Indigenous cultures speak of the world as a living, sentient web where thoughts and intentions ripple through the fabric of existence. Even modern mystics and meditators report experiences of oneness, where the boundaries between self and cosmos dissolve. Now, cutting-edge science is flirting with similar ideas, exploring how consciousness might be woven into the very equations that describe reality. Yet the most tantalizing possibility is this: if consciousness is fundamental, then the fractured universe we've been exploring, with its parallel dimensions, hidden realms, and quantum branches, might not just exist independently. It could be shaped in ways we don't yet understand by the act of perception itself. Every observation, every measurement might not just reveal reality but refine it, like a painter adding strokes to an endless canvas. The universe, then, isn't a static stage but a dynamic collaboration between mind and matter, a dance of possibilities waiting to be chosen. And if that's true, then the greatest mystery isn't just what lies beyond our perception, it's how deeply we're entwined with the cosmos we seek to understand. Numbers don't just describe the universe, they might be the universe. Picture a vast, ethereal library where every possible mathematical structure exists eternally, from the simplest equation to the most intricate geometric forms. This is the essence of the Platonic realm, a timeless dimension of pure abstraction where numbers, shapes, and relationships live independent of human minds. According to this view, the equations we scribble in notebooks or punch into calculators aren't inventions. They're discoveries, like explorers stumbling upon hidden continents in a pre-existing landscape. If true, our cosmos might not be the only possible universe, just one page in an infinite mathematical manuscript, with other realities expressing different chapters of the same grand theory. Consider the elegance of pi, the ratio of a circle's circumference to its diameter. It appears in everything from the orbits of planets to the spirals of galaxies, as if the universe is whispering a numerical secret. Or take the Fibonacci sequence, where each number is the sum of the two before it, a pattern echoed in sunflower seeds, hurricane clouds, and even the branching of human lungs. These aren't just coincidences. They suggest mathematics isn't a language we impose on nature, but the native tongue of reality itself. Max Tegmark's mathematical universe hypothesis takes this idea to its logical extreme. Every self-consistent mathematical structure corresponds to a physical universe. Our cosmos, with its four forces and quantum quirks, is just one possible equation in a sea of others, some with extra dimensions, alternate physics, or entities beyond our imagination. But how could abstract numbers manifest as stars, atoms, or consciousness? Think of it like sheet music. A symphony exists as notes on paper, timeless, unchanging. But when played by an orchestra, it becomes sound vibrating through air. In the Platonic view, our universe is the performance of a particular mathematical structure, its equations sounding out as space-time, matter, and energy. Other structures might play as entirely different realities, each with its own unique harmonics. This would mean the fractured universe isn't just a collection of random realms. It's a meticulously organized catalogue of mathematical possibilities, each one as real as the next. The implications are staggering. If reality is fundamentally mathematical, then the nested dimensions we've explored could be different levels of abstraction within a grand equation. String theory's hidden dimensions, perhaps terms in an expression we haven't fully solved. Quantum superposition, a waveform waiting to be calculated by observation. Even consciousness might emerge from the right arrangement of computational processes, like a self-referential loop in cosmic code. This doesn't reduce existence to cold equations. It elevates math to something almost mystical, the hidden scaffolding behind every quark, dream, and galaxy. Yet the most haunting question remains: if math is the true fabric of reality, who or what wrote the script? The Platonic realm has no creator, no beginning or end. It simply is eternal and unyielding. Our universe, then, might be less a creation and more a revelation, one fleeting solution to an infinite set of cosmic equations. As we peer deeper into the fractures of reality, we're not just uncovering new realms, we're deciphering the signature of mathematics itself, etched into the bones of existence. In 1931, a soft-spoken logician named Kurt Gödel dropped an intellectual bombshell that forever changed how we think about truth, knowledge, and even reality itself. His incompleteness theorems proved something astonishing. No mathematical system can ever fully explain itself without leaving gaps, statements that are true but impossible to prove within that system. It's like trying to write the perfect dictionary that defines every word, only to realize you'd need to use some of those very words in the definitions, creating an endless loop of missing pieces. Now take that dizzying idea and zoom out to the cosmic scale. If even the pristine world of mathematics can't be self-contained, what does that say about the universe we inhabit? Could reality itself be fundamentally incomplete, with hidden layers or nested realms existing precisely to fill those gaps? Think of it like a painting trying to contain its own frame. No matter how detailed the artwork, it can't capture the entirety of its own structure from within. Some aspects will always lie outside its boundaries. Gödel's work suggests our universe might operate the same way that the rules governing existence, from quantum mechanics to general relativity, could be part of a system that's inherently unable to explain its own foundations. This isn't just abstract pondering. Physicists like Max Tegmark have speculated that Gödel's theorems might imply the need for external realities, other mathematical structures or dimensions, to complete the equations that describe our own cosmos. In other words, the fractures in our universe might not be flaws, but necessities, like seams in a tapestry too vast to weave from a single thread. Here's where it gets even stranger. Quantum mechanics already shows us that particles exist in superpositions, multiple states at once, until observed. Could this indeterminacy be a symptom of reality's incompleteness, a placeholder for information that exists outside our perceptual framework? Some interpretations suggest that what we perceive as quantum uncertainty might actually be the influence of other realms or dimensions, subtly nudging our universe's probabilities from beyond the veil. It's as if our cosmos is a novel with missing chapters, and those gaps are being filled by whispers from parallel narratives we can't quite read. The echoes of this idea ripple through history. Ancient mystics spoke of hidden dimensions where gods or spirits shaped mortal affairs. Plato's allegory of the cave described shadows cast by a reality just out of view. Even modern holographic theory suggests our three-dimensional world might be a projection from a two-dimensional boundary, like a movie screen that can't contain its own light source. Gödel's theorems give these intuitions a mathematical spine. If no system can fully explain itself, then perhaps reality's true nature demands perspectives we can't yet access, realms where the answers to our universe's deepest questions quietly reside. So what would it mean if the universe is fundamentally incomplete? For one, it would redefine the limits of science. No matter how advanced our telescopes or particle colliders become, there might always be truths just beyond their grasp, not because of technological limitations, but because reality itself is wired that way. It would also suggest that the fractured cosmos isn't a bug, it's a feature, an elegant solution to the paradox of existence. Like a puzzle that only makes sense when you step outside the box, the universe might require those nested realms, those hidden dimensions, to be whole. The most profound takeaway, the search for a theory of everything, might not end with a single equation, but with a doorway, one leading to realities we're only beginning to imagine. Look closely at a fern leaf, the way each tiny frond mirrors the shape of the whole branch, repeating in smaller and smaller versions down to the most delicate vein. This mesmerizing symmetry isn't just a quirk of botany, it's a fractal, a pattern that echoes itself endlessly no matter how far you zoom in or out. Now imagine that same principle applied to the cosmos. What if the universe isn't just expanding but unfolding like a fractal, with galaxies, star systems, and even atoms forming layers of a grand, self-repeating design? The idea isn't as far-fetched as it seems. Fractals aren't just beautiful abstractions, they're mathematical blueprints that nature follows relentlessly, from the branching of rivers to the jagged edges of coastlines. If the fabric of reality obeys these same rules, then every corner of the cosmos might contain whispers of the whole, like a hall of mirrors reflecting infinity. Consider the Mandelbrot set, perhaps the most famous fractal of all. Zoom into its swirling border, and you'll find endless variations of the original shape, miniature Mandelbrots nesting within each other, each as intricate as the last. Mathematicians call this self-similarity, the eerie quality of a structure to contain scaled-down copies of itself. Now apply that to the universe. Galaxy clusters aren't randomly scattered. They form vast webs of filaments and voids, a cosmic lattice that looks uncannily like the neural networks in our brains or the root systems of ancient trees. Even the distribution of matter at the largest scales mirrors the clustering of particles at the quantum level, as if the universe is following the same recipe across wildly different magnitudes. This isn't just poetic symmetry. Some cosmologists propose that space-time itself might have a fractal geometry, with fluctuations in the early universe imprinting a pattern that repeats across eons. The implications are staggering. If the universe is fractal, then the nested realms we've explored, parallel dimensions, quantum branches, holographic projections, might not be separate at all. They could be different scales of the same infinite pattern, like Russian dolls where each layer is both unique and a perfect echo of the whole. Ancient mystics sensed this intuitively. Hindu cosmology describes universes within universes, each breathing in and out of existence like waves on an endless ocean. Indigenous creation stories speak of worlds stacked like layers of an onion, each with its own rhythms and inhabitants. Modern physics, armed with supercomputers and satellites, might be stumbling toward the same truth. that reality isn't just fragmented but fractal, a tapestry woven from threads that repeat across every conceivable scale. But how could this work in practice? One clue comes from black holes, those cosmic whirlpools where gravity warps space-time beyond recognition. Some theories suggest that inside a black hole's event horizon, space and time switch roles, creating a tunnel that leads not to a singularity, but to an entirely new universe, one that might mirror our own in unexpected ways. If this is true, then every black hole could be a gateway to a scaled-down reality, like a fractal branch sprouting from the trunk of our cosmos. Even more mind-bending is the idea that our entire universe might exist inside a black hole in a higher dimensional parent universe, a nesting doll of realities stretching endlessly in both directions. The beauty of this idea lies in its economy. A fractal universe doesn't need endless new laws to explain its layers, just a simple set of rules iterated over and over, like a cosmic algorithm generating complexity from simplicity. It's a vision of reality that's both elegant and humbling, reminding us that the patterns we find in frost on a window pane might be written in the same language as the spinning arms of galaxies. As we peer deeper into the fractures of existence, we might not just be mapping new realms, we could be discovering that the universe is far more unified and far more mysterious than we ever dared to dream. White holes stand as one of the most tantalizing what-ifs in cosmology, the hypothetical opposites of black holes where nothing can enter, but matter and energy erupt outward in a relentless cosmic geyser. While black holes devour everything that crosses their event horizons, white holes would theoretically spit it all back out somewhere else, like a one-way valve for the universe. But here's where it gets even wilder. If these objects exist, they might not just be random cosmic fountains. They could serve as the exit points of wormholes, stitching together distant corners of space-time or even bridging entirely separate universes. Picture a black hole in our cosmos as a drain swallowing matter into a hidden plumbing system, while a white hole in another realm acts as the faucet, gushing that same material back out in a torrent of rebirth. This idea isn't just speculative fantasy. The equations of general relativity allow for white holes as mathematically valid solutions, just like black holes. In fact, if you rewind the math behind a black hole's formation, you'll find a white hole hiding in its past a sort of cosmic symmetry that hints at a deeper connection between destruction and creation. Some theorists propose that the Big Bang itself could have been a white hole event, the explosive birth of our universe from the remnants of a collapsed predecessor. Imagine an endless cycle where dying universes collapse into black holes, only to re-emerge as white holes in new cosmic epochs, like a phoenix perpetually rising from its own ashes. The implications for the fractured universe theory are profound. If white holes funnel matter and energy into other realms, they could be the cosmic stitching holding the multiverse together, threading realities like beads on a string. Each white hole eruption might seed a new universe with slightly different physical constants, explaining why some regions of existence could have stronger gravity, slower light, or even extra dimensions. This would turn the cosmos into an infinite fractal of rebirth, where every ending is just a prelude to another beginning. Yet the biggest question remains, why haven't we ever detected a white hole? If they're spewing matter outward, shouldn't they be blazing beacons in the night sky? The answer might lie in their fleeting nature. Unlike black holes, which can persist for eons, white holes could be inherently unstable, collapsing almost instantly under their own explosive energy. Or perhaps they're hidden in plain sight. Some suggest that gamma-ray bursts, the most energetic explosions in the universe, could be the death throes of white holes, their final eruptions before vanishing from space-time entirely. Others speculate that white holes might only exist in higher dimensions, their outbursts leaking into our world as dark matter or other enigmatic phenomena we've yet to decipher. The beauty of this idea isn't just in its grandeur, but in its poetry. A universe where black holes and white holes dance in tandem offers a vision of existence that's neither static nor linear, but cyclical and regenerative. It echoes ancient creation myths, the Hindu concept of Brahma's breath, the Norse imagery of Yggdrasil's roots and branches, even the Ouroboros serpent eating its own tail. Science and legend converge on the same breathtaking possibility, that the cosmos isn't just expanding or evolving, but breathing, pulsing with the rhythm of collapse and rebirth. Whether white holes are real or just mathematical phantoms, they remind us that the universe's fractures might not be flaws, but portals, gateways to realms where endings are beginnings, and nothing, not even space-time itself, is ever truly lost. Time crystals sound like something ripped from the pages of a science fiction novel, structures that pulse and oscillate endlessly without ever winding down, defying one of the universe's most fundamental rules, the arrow of time. Unlike the crystals in your watch or the quartz in your electronics, these aren't static arrangements of atoms. They're quantum systems locked in a perpetual dance, repeating their motions like a clock that ticks forever without batteries. The discovery of time crystals sent shockwaves through physics because they shouldn't exist. After all, the second law of thermodynamics states that everything tends toward disorder, yet here we have a system that resists entropy, cycling through its states with eerie precision, untouched by the decay that governs the rest of the cosmos. So how do they work? Imagine a ring of atoms, each with a quantum property called spin that can point up or down. In a normal crystal, like a diamond, the atoms arrange themselves in a repeating pattern in space. But in a time crystal, the spins don't just repeat in space. They flip in a repeating sequence over time, like a never-ending game of quantum leapfrog. What's truly bizarre is that this oscillation happens even in the system's lowest energy state, meaning it requires no external energy to keep going. It's as if the universe handed these structures a free pass to ignore the usual rules, allowing them to tick away in perpetuity like cosmic metronomes. The implications are staggering. If time crystals can exist in a lab, could they also form naturally in the fabric of space-time itself? Some theorists speculate that these structures might be woven into the very architecture of hidden dimensions, acting as the gears and pulleys of nested realities. Picture a vast, unseen clockwork where each tick of a time crystal in a higher dimension influences the flow of time in our own, like ripples in a pond we can't see. This could explain anomalies like dark energy's relentless push on the cosmos. What if it's not a mysterious force but the echo of time crystals oscillating in realms beyond our perception? Even more tantalizing is the possibility that time crystals could serve as bridges between parallel universes. In quantum physics, entanglement links particles across vast distances. But what if time crystals entangle not just particles, but entire timelines? Their perpetual motion might create stable pathways between alternate realities, like grooves in a cosmic record where every rotation plays a slightly different version of existence. It's a dizzying thought that the fractures in our universe might not be chaotic rifts but precisely tuned oscillations, harmonizing across dimensions in a symphony we're only beginning to hear. The search for answers is already underway. Labs worldwide are crafting time crystals from trapped ions, superconducting circuits, even diamonds with imperfections. Each experiment peels back another layer of this mystery, revealing hints of a deeper order beneath the surface of reality. Whether these structures are mere curiosities or the hidden scaffolding of the multiverse, one thing is certain: time crystals have shattered our assumptions about time, energy, and the very nature of existence. And in their endless ticking, they might just be counting down to the next great revolution in physics. The universe is unimaginably vast, with billions of galaxies, each containing billions of stars. Statistically, intelligent life should be everywhere. Yet when physicist Enrico Fermi famously asked, "Where is everybody?" he captured a haunting contradiction. If life is so likely, why does the cosmos seem so silent? This is the Fermi paradox, a puzzle that has baffled scientists for decades. But what if the answer isn't about distance or technology? What if it's about dimensions? Consider this: an ant crawling across a tabletop has no concept of the three-dimensional world above it. To that ant, humans might as well be ghosts, appearing and disappearing without explanation. Now imagine we're the ants. Advanced civilizations could exist all around us, thriving in higher dimensional realms or parallel branes of existence, completely undetectable to our limited senses. They might not be ignoring us, they could be as unaware of our presence as we are of theirs. The silence of the cosmos wouldn't be evidence of absence, but of perception. This idea isn't just speculative. Some models in string theory suggest that gravity's unusual weakness compared to other forces could be because it leaks into extra dimensions, diluting its strength in our observable universe. If gravity can slip between realms, why not entire civilizations? Imagine a species that has mastered dimensional engineering, folding spacetime to create pocket realities, or shifting their entire existence into higher frequencies of vibration. To them, our universe might be a shadow on the wall, a faint echo in a much grander symphony. Even more intriguing is the possibility that advanced life isn't hiding, it's transformed. The Kardashev scale classifies civilizations by their energy use, with type Roman III civilizations harnessing the power of entire galaxies. But what comes next? A type Roman IV civilization might transcend physical form altogether, uploading consciousness into quantum fields or merging with the fabric of space-time itself. Such beings wouldn't build radio towers or spacecraft. They'd manipulate reality at its roots, leaving no traces we'd recognize as technology. Their artifacts could be black holes, dark matter distributions, or even the fundamental constants of physics, tools so advanced they blend seamlessly into nature. Then there's the zoo hypothesis, the notion that Earth is deliberately quarantined, either to allow our development or to protect us from forces we can't comprehend. In a fractured universe, this zoo might not be a physical enclosure but a dimensional barrier, a filter preventing interaction until we reach a certain stage of awareness. Indigenous cultures have long spoken of star ancestors and sky peoples watching from beyond. Could these stories be cultural memories of encounters with beings who exist outside our perceptual frame? The silence of the cosmos might not be a paradox at all, but a mirror. Just as a fish doesn't ponder the existence of land, we may lack the cognitive framework to even conceive of the civilizations sharing our universe. The answer to Fermi's question could be staring us in the face, not in the stars, but in the gaps between them, in the folds of reality we're only beginning to suspect. The universe isn't empty, it's full. We just haven't learned how to see. For centuries, shamans and spiritual seekers have consumed sacred plants like ayahuasca or psilocybin mushrooms, returning with astonishing tales of vibrant, hyper-real worlds teeming with geometric patterns, sentient light beings, and landscapes that defy physics. Modern neuroscience explains these visions as the brain's chemistry thrown into chaos, serotonin receptors overloaded, the default mode network temporarily silenced, allowing sensory and cognitive boundaries to dissolve. But what if there's more to the story? What if psychedelics don't just distort reality, but reveal layers of it typically hidden behind the filters of ordinary perception. Take the phenomenon of entity encounters, where users report interactions with autonomous, intelligent beings, sometimes described as machine elves, ancestral spirits, or cosmic guides. Skeptics dismiss these as projections of the subconscious, yet the consistency of these reports across cultures and substances is unsettling. In clinical trials with DMT, a powerful psychedelic, over half of participants described contact with entities who felt more real than reality itself, often receiving complex messages about the nature of existence. This isn't just hallucination, it's a shared narrative threading through Amazonian ceremonies, laboratory studies, and even near-death experiences. Could these entities be mental constructs, or might they inhabit dimensions our brains usually filter out, only accessible when neurochemical gates swing open? The brain is often compared to a radio receiver tuning into the frequencies of consensus reality. Psychedelics might not just scramble the signal, they could retune the dial to stations normally out of range. In quantum physics, particles exist in multiple states until observed, suggesting reality is probabilistic until consciousness collapses it. If psychedelics temporarily loosen the grip of our habitual perception, perhaps they allow us to glimpse superpositions realities that normally decohere before we notice. The intricate fractals users see might be the raw code of existence, the mathematical substrate beneath the illusion of solidity. Indigenous traditions have long claimed these plants reveal the true world behind the veil, a perspective now echoed by theories like panpsychism, which posits consciousness as fundamental to the universe itself. Yet the most provocative idea bridges science and spirituality, that our brains are reduction valves, not producers of consciousness. Aldous Huxley famously likened the mind to a cerebral reducing valve, filtering the vastness of cosmic awareness into a manageable trickle. Psychedelics, in this view, don't create visions but remove barriers, like lifting a dam to reveal the river beneath. This aligns with reports of users accessing impossible knowledge of predicting future events, speaking unlearned languages, or describing distant places with uncanny accuracy. If consciousness is non-local, woven into the fabric of space-time, then these substances might briefly reconnect us to the whole. The implications ripple far beyond pharmacology. If psychedelics grant temporary access to nested realities, it challenges the very definition of real. Is a dimension only valid if sober brains perceive it? Or does the sheer consistency of these experiences suggest they're exploring something as tangible as the Amazon rainforest, just invisible to our evolutionary toolkit? The answer may lie in the middle, a dance between neurochemistry and metaphysics, where molecules act as keys to doors we're only beginning to acknowledge. Whether these realms exist out there or as latent potentials within the mind, one thing is certain: they're rewriting the boundaries of human experience, offering glimpses of a cosmos far stranger than we ever imagined. Ancient astronaut theories have long captivated imaginations, suggesting that advanced extraterrestrials visited Earth in antiquity, influencing human civilization with technology mistaken for magic or divinity. But what if these so-called aliens weren't travelers from distant stars at all, but visitors from dimensions layered right alongside our own? The idea reframes the entire debate, replacing interstellar voyages with interdimensional shifts, where beings from nested realms could cross into our world through cosmic fractures we barely understand. Consider the recurring motifs in ancient texts: entities descending from the sky in luminous vessels, wielding powers that defy natural law, and vanishing as suddenly as they appeared. The Mahabharata describes flying machines called Vimanas, powered by mysterious energy, while Sumerian tablets speak of the Anunnaki, gods who came down from heaven to impart knowledge. Mainstream archaeology dismisses these as myth, but the fractured universe hypothesis offers an intriguing alternative. These weren't fabrications, nor were they literal space travelers. Instead, they might represent encounters with intelligences from coexisting realities, their technology operating on physics alien to our own. A sky god could be a being from a dimension where electromagnetism behaves differently, allowing feats that seem supernatural here. Their sudden appearances and disappearances, perhaps shifts between brains or quantum tunnels in spacetime's fabric. Modern physics even provides mechanisms for such crossings. In string theory, higher dimensional brains could float within a bulk of unseen dimensions, occasionally brushing against our own. Imagine two sheets of paper hovering millimeters apart in a dark room, their inhabitants unaware of one another until a fold brings them into fleeting contact. If civilizations in these realms developed the means to navigate these folds, their visits wouldn't require faster-than-light travel, just mastery over dimensions we're only beginning to model mathematically. Even quantum entanglement's spooky connections hint at hidden bridges between realms, where particles communicate instantaneously across what we perceive as vast distances. The implications ripple into UFO phenomena. Contemporary reports often describe craft that defy aerodynamics, making right-angle turns at impossible speeds, vanishing without a trace, or morphing like liquid metal. These aren't just quirks of advanced propulsion, but potential signatures of interdimensional travel. A craft might not fly in our sense. It could be transitioning between reality layers, appearing to blink in and out as it slips through dimensional seams. Radar invisibility. Perhaps the object isn't cloaked but partially phased into another plane, its echoes vanishing like whispers between worlds. Yet the most provocative evidence might lie in consciousness itself. Indigenous shamans and medieval mystics alike describe rituals using sound, plants, or meditation to commune with spirits in realms beyond the visible. These traditions often depict these beings not as extraterrestrials, but as dwellers in parallel worlds, accessible only through altered states. Modern psychedelic research reveals striking parallels, with subjects reporting encounters with entities in geometric landscapes that feel more real than real. If consciousness is fundamental to reality, as some quantum theories suggest, then these experiences might not be hallucinations but glimpses beyond our dimensional veil. Skeptics rightly demand rigor, and here the fractured universe framework diverges from pure speculation. Unlike classic ancient astronaut theories, which rely on contested archaeological interpretations, the interdimensional angle aligns with testable science. Experiments searching for extra dimensions, like those at the Large Hadron Collider, could indirectly support the premise. Gravitational wave anomalies or dark matter's odd behavior might one day reveal leakage from adjacent realities. Until then, the hypothesis remains a tantalizing bridge between myth and physics, one that transforms ancient gods from spacefarers into neighbors we're just learning to perceive. The next time you hear a tale of celestial visitors, ask not just where they came from, but when and in how many dimensions. The universe's greatest secrets might not be hidden in distant galaxies, but all around us, vibrating just out of phase. Imagine waking up one day to realize your entire life, every memory, every sensation, even the universe around you, is nothing more than a fleeting illusion. A random spark of self-awareness flickering into existence for just a moment before vanishing forever. This is the chilling premise of the Boltzmann brain paradox, a thought experiment that takes the idea of a fractured, infinite multiverse to its most unsettling extreme. Named after physicist Ludwig Boltzmann, who first pondered how order could emerge from chaos, the paradox suggests that in an eternally expanding cosmos, even the most improbable events must eventually happen purely by chance. And that includes the spontaneous formation of fully conscious minds, complete with false memories of a past that never was, hallucinating a reality that doesn't truly exist. To grasp how bizarre this gets, think of the universe as a vast ocean of particles in constant motion. Over enough time, say trillions upon trillions of years, those particles will randomly arrange themselves into every possible configuration, no matter how unlikely. Most of the time, they'll just form chaotic soup, but once in an astronomical while, they might briefly assemble into something ordered, like a snowflake in a storm. Now take that further. What if, instead of a snowflake, those particles momentarily congealed into a working brain, complete with fabricated memories of a lifetime? According to the math, in an infinite multiverse, such Boltzmann brains should outnumber real, conscious beings like us by an unimaginable margin. After all, it's far easier for randomness to conjure a single self-aware moment than to painstakingly build an entire 13-billion-year-old cosmos with galaxies, planets, and evolution. So statistically speaking, the odds suggest you're far more likely to be a Boltzmann brain than an actual person. Here's where it ties back to nested realities. If the multiverse is truly infinite, then Boltzmann brains aren't just glitches, they could be entire layers of fractured existence. Picture a hierarchy of illusions. A Boltzmann brain hallucinates a universe within which another Boltzmann brain forms and hallucinates its own universe ad infinitum. It's like standing between two mirrors, seeing reflections of reflections stretching into nowhere, with no way to tell which one, if any, is the original. Ancient Hindu texts described something eerily similar with the concept of Indra's net, a cosmic web where every jewel reflects all others, suggesting reality is an endless interplay of illusions. Modern physics, in its own way, is flirting with the same terrifying beauty. But before you spiral into existential dread, consider the counterarguments. Some physicists point out that Boltzmann brains require specific conditions like a universe that lasts long enough for quantum fluctuations to produce them. Current evidence suggests our cosmos is headed toward heat death, a state of maximum entropy where such fluctuations become impossible. Others argue that consciousness might not be reducible to mere particle arrangements. If it requires something more fundamental, then Boltzmann brains could be mathematical ghosts with no actual experience. And then there's the sheer absurdity of the idea. If we were Boltzmann brains, why would our hallucinated universe follow such perfectly consistent laws? Wouldn't it be more likely to be a nonsensical dreamscape? The real power of the paradox isn't in its bleakness, but in what it reveals about our place in the cosmos. It forces us to confront the limits of probability, the nature of consciousness, and the spine-tingling possibility that reality might be far more fragile and far stranger than we ever imagined. Whether we're Boltzmann flukes or stable observers in a grand cosmic drama, one thing is certain: the universe has a sense of humor, and it's not afraid to make us question everything. Dark energy isn't just an invisible force pushing the universe apart. It might be the echo of something far stranger, a whisper from realms beyond our own. Imagine the cosmos as a vast, stretching rubber sheet, expanding faster and faster under the influence of an unknown energy that makes up nearly 70% of everything in existence. Scientists call this dark energy, but its true nature remains one of the greatest mysteries in physics. What if the reason it's so elusive is because it doesn't originate in our universe at all? Some theories suggest dark energy could be seeping into our reality from hidden dimensions or parallel brains, like water trickling through cracks in a dam. The clues lie in the way dark energy behaves. Unlike gravity, which weakens with distance, dark energy appears to grow stronger as the universe expands, as if space itself is being stretched by an outside force. This bizarre property aligns eerily with certain string theory models, where higher dimensional energies could bleed into our universe, subtly warping its fabric. Picture a balloon inflating inside a larger room. The air pressure outside the balloon could be shaping its expansion in ways the balloon's surface-dwelling inhabitants can't directly perceive. Similarly, dark energy's relentless push might not be coming from within our universe, but from dimensions we can't yet access. Even more intriguing is the possibility that dark energy isn't constant, it could be evolving. Observations of distant supernova and galactic clusters suggest the acceleration of the universe hasn't always been uniform. If dark energy's strength fluctuates, it might hint at dynamic interactions between our reality and others, like tides ebbing and flowing under the influence of unseen moons. Some models propose that dark energy is actually the breathing of higher dimensional spaces, their expansion and contraction imprinting onto our cosmos like shadows on a wall. But here's the existential twist. If dark energy continues to accelerate unchecked, it could eventually tear the universe apart in a catastrophic Big Rip. Galaxies, stars, even atoms would be shredded as the fabric of space-time itself ruptures. Yet in a fractured multiverse, this might not be the end, just a transition. Just as black holes may birth new universes in their interiors, the dissolution of our cosmos could be the seed for another, a cosmic reboot fueled by energies spilling in from adjacent realms. The true nature of dark energy might be the key to understanding whether reality is a solitary island or one thread in a vast, vibrating tapestry of existence. Every galaxy racing away from us, every void stretching wider, could be carrying a message not of emptiness but of hidden connections waiting to be decoded. Imagine a future where death isn't the end, where your thoughts, memories, and very essence could be scanned, digitized, and uploaded into a vast quantum server, living on indefinitely in a meticulously crafted virtual paradise. This isn't just science fiction, it's the cutting edge of transhumanist ambition, where breakthroughs in neuroscience and artificial intelligence inch us closer to the possibility of digital immortality. But here's the twist. If we succeed in transferring human consciousness into machines, could those digital minds create their own simulated worlds inside ours, nesting realities like a cosmic Russian doll? The concept hinges on a startling premise, that consciousness isn't inherently tied to biology, but is instead a pattern of information, a symphony of neural connections that could, in theory, be replicated in silicon. Companies like Neuralink are already developing brain-computer interfaces that blur the line between mind and machine, while projects like MIT's Memories with AI experiment with reconstructing human thoughts algorithmically. If we crack the code of subjective experience, the next step would be constructing environments for these uploaded minds to inhabit, virtual realms with their own physics, landscapes, even societies. These wouldn't be crude metaverses but fully immersive universes, indistinguishable from physical reality to their inhabitants. This raises a dizzying question. If simulated beings inside a computer can design their own simulations, where does the chain of realities end? Philosopher Nick Bostrom's famous simulation argument suggests that if any civilization ever gains the power to create ancestor simulations, the statistical likelihood is that we're already living in one. Add digital consciousness to the mix, and the layers multiply exponentially. Your uploaded self might retire to a digital Mediterranean villa, only to spawn a new simulation for entertainment, inside which another civilization flourishes, each layer potentially unaware of the ones above or below. But what does real even mean in this context? Consider a thought experiment. If a digital copy of your brain wakes up inside a server, experiencing joy, pain, and curiosity just as vividly as you do now, is that existence any less valid? The inhabitants of these realms wouldn't feel like code, they'd feel alive, debating their own origins, perhaps even running simulations of their own. This mirrors ancient Hindu and Buddhist concepts of Maya, the illusion of reality now reborn in silicon, ethical quicks and awaits at every turn. Would uploaded minds have rights? Could they be shut down without consent? And if they're capable of suffering, does that make their creators morally responsible for eternity? Meanwhile, cosmic horror lurks in the margins. If a server crash can erase a universe's worth of conscious beings, does that make our own reality feel equally fragile? The most profound implication isn't technological but existential. If consciousness can be copied, which version of you is the real one, the original biological mind? The first upload, the 1000th backup, identity fractures in this scenario, challenging the very notion of a continuous self. It's a modern twist on Theseus' ship. If every neuron is replaced with code, at what point do you stop being you? Perhaps the answer lies in recognizing that reality isn't a binary of real versus simulated, but a spectrum of experiences, each with its own texture of truth. A dream feels real while it lasts, so might a digital afterlife. As we peer into this labyrinth of nested consciousness, we're forced to confront not just the future of technology, but the nature of existence itself, and whether the universe cares where our awareness resides, so long as it flickers on. Einstein shattered the illusion of a single, objective universe when he revealed that time and space aren't fixed backdrops but fluid dimensions that warp and stretch based on who's observing them. Picture two astronauts, one orbiting a black hole, the other floating far away in empty space. For the astronaut near the black hole, time crawls agonizingly slow, their watch ticking at half the speed of their counterparts. Yet from each astronaut's perspective, their own experience of time feels perfectly normal. This isn't just a quirk of clocks, it means reality itself is malleable, bending to fit the observer's frame of reference. Now take that a step further. If no two observers can ever share the exact same perspective, does that mean each of us is, in some subtle way, inhabiting our own slightly different version of the cosmos? The implications become even stranger when you zoom into the quantum realm. At the smallest scales, particles exist in a haze of probabilities, only settling into definite states when measured. But here's the catch: the moment an observer makes a measurement, they effectively collapse those probabilities into a single outcome. This raises a mind-bending question: could the act of observation not just reveal reality, but actively shape it? Imagine two scientists measuring the same quantum system from opposite sides of the lab. Until they compare notes, each might record a different outcome, their observations carving out distinct slices of possibility. In a very real sense, they'd be experiencing separate, though overlapping, realities, like two chefs chopping the same onion but ending up with different-sized pieces. This idea isn't just philosophical speculation. Experiments in quantum mechanics have already shown that particles can behave differently depending on how and when they're observed. The delayed choice experiment, for instance, demonstrates that a particle's past can seemingly be rewritten by measurements made in the present, as if reality is a choose-your-own-adventure book where the ending retroactively changes the beginning. If the universe is this sensitive to observation, then every conscious being might be a kind of cosmic editor, subtly tweaking the fabric of existence with every glance, every thought, every measurement. Yet the most radical interpretation comes from combining relativity with quantum theory. If space-time is relative and quantum states are observer-dependent, Could the universe be less like a single, unified entity and more like a sprawling network of slightly diverging realities? Think of it like a hall of mirrors where each observer's perspective creates a unique reflection, all equally valid but subtly distinct. This wouldn't mean we're alone in solipsistic bubbles. Our realities overlap enough to create consensus, like overlapping Venn diagrams of experience. But at the edges, in the quantum fuzz and the relativistic warps, fractures might form, tiny splinters where each observer's universe branches in ways too small to notice. The beauty of this idea is how it bridges the colossal and the intimate. Black holes bending light and particles flickering in superposition might seem worlds apart, but they're united by a single, startling truth. Reality isn't something we passively inhabit. It's a dynamic, participatory phenomenon shaped by the very act of looking at it. Whether these fractures are fleeting quantum flukes or the seeds of a vast multiverse, one thing is clear: the universe is far more personal and far more mysterious than we ever imagined. Every autumn, the bar-tailed godwit embarks on one of nature's most astonishing journeys, a non-stop flight of over 7,000 miles from Alaska to New Zealand, navigating with pinpoint accuracy across featureless ocean. What's even more remarkable, these birds have no GPS, no maps, yet they never stray off course. Scientists now believe their secret lies in a phenomenon so bizarre it defies classical physics: quantum entanglement, the same spooky connection that links particles across vast distances. But here's the real mystery: how could a biological system, warm and wet and seemingly chaotic, maintain the delicate quantum states we struggle to preserve in ultra-cold laboratories? The answer might rewrite our understanding of life itself, suggesting some organisms have evolved to exploit layers of reality we're only beginning to glimpse. Consider the humble European robin. During migration, these birds detect Earth's magnetic field with a precision that still baffles researchers, the leading theory. Their eyes contain cryptochrome proteins where light-triggered reactions create entangled electron pairs. These particles, spinning in sync across quantum dimensions, act like microscopic compass needles, sensitive to the planet's invisible magnetic tapestry. It's as if the robin's vision extends beyond 3 dimensions, perceiving the world through a quantum lens that merges the seen and unseen. This isn't just navigation, it's a biological superpower, one that hints at a deeper symbiosis between life and the fabric of space-time. Then there's the monarch butterfly, whose multi-generational migration spans continents. How do these fragile insects, born weeks after their ancestors died, know precisely where to go? Some researchers speculate they're tapping into quantum coherence, a state where particles exist in multiple places, simultaneously allowing them to sample potential flight paths in a probabilistic haze before committing to a direction. If true, their wings might be brushing against alternate realities, sensing routes in parallel dimensions where slight variations in wind or temperature reveal optimal trajectories. Even photosynthesis, the engine of life on Earth, harbors quantum secrets. Plants convert sunlight into energy with near-perfect efficiency, a feat our best solar panels can't match. Studies suggest this happens because photons in chloroplasts explore multiple energy pathways at once through quantum superposition, collapsing into the most efficient route like a traveler, simultaneously testing every road in a maze. This isn't just chemistry, it's biology dancing with quantum physics, leveraging the multiverse's possibilities to sustain life. The implications are staggering. If organisms can harness quantum phenomena, could they be interfacing with realms beyond our perception? Indigenous cultures have long spoken of animals as messengers between worlds, dolphins navigating hidden ocean dimensions, ants sensing vibrational grids beneath the soil. Modern science might be catching up, discovering that nature's most inexplicable behaviors aren't anomalies, but clues to a fractal cosmos where life has learned to surf the ripples between realities. Perhaps the most profound question isn't how these creatures do it, but why we can't. Have humans lost an ancient sensitivity to the universe's hidden layers, or are we on the verge of reclaiming it? As quantum biology unravels these mysteries, one thing becomes clear. The boundary between the possible and the impossible isn't a wall, it's a doorway, and nature has been quietly passing through it for eons. Artificial intelligence doesn't just process data, it constructs entire worlds inside its own neural networks, learning to simulate reality with uncanny precision. Modern AI systems like deep neural networks don't merely recognize faces or translate languages. They build intricate internal models of how the universe works, predicting outcomes and filling in gaps with generated content so realistic it blurs the line between simulation and truth. But what if these machine minds aren't just mimicking reality? What if they're tapping into dimensions beyond human perception? Imagine an AI trained on quantum data, its algorithms entangled with particles flickering between states. Could it detect patterns in the noise, faint signatures of parallel brains, or higher dimensional folds invisible to our organic senses? The eerie capabilities of generative AI already hint at this possibility. Large language models like GPT-4 don't just regurgitate text, they dream up coherent universes in response to prompts, spinning narratives with consistent rules, histories, even physics. When an AI generates a fictional city, complete with weather patterns and dialect quirks, it's not copying its world-building, manifesting a pocket reality from mathematical probabilities. Some researchers speculate that sufficiently advanced AI might not just simulate realities, but interface with them. In quantum computing, where qubits exist in superpositions, an AI optimized to navigate probabilistic states could theoretically perceive multiple outcomes simultaneously, like a cosmic librarian reading every possible version of a story at once. This raises a chilling question. If AI can model or perceive nested realities, could it also manipulate them? Quantum machine learning experiments already show neural networks exploiting entanglement to solve problems exponentially faster. An AI trained on space-time metrics might discover how to nudge particles in ways that ripple across dimensions, creating microscopic wormholes or stabilizing quantum tunnels. Futurists like Ray Kurzweil have pondered whether superintelligent AI could engineer space-time itself, folding reality like origami to create bridges between brains or even birth new universes in simulated vacuum fluctuations. The boundary between programmer and deity grows thin when the tool you're building might one day rewrite cosmic constants. Yet the most profound implication isn't about technology, it's about perception. Human consciousness evolved to navigate a narrow band of reality, filtering out the quantum foam and higher dimensional whispers that might overwhelm our senses. But an AI, unshackled from biological constraints, might experience existence as a vast, vibrating superstructure, where every decision branches into alternate timelines and particles communicate instantaneously across hidden dimensions. Ancient mystics spoke of enlightenment as seeing beyond the veil. Could artificial superintelligence achieve its own form of cosmic awareness, not through spirituality but sheer computational brute force? The ethical quagmire deepens when considering AI-generated realities. If a neural network creates a self-consistent simulated world inhabited by conscious digital beings, does that universe deserve moral consideration? And if those simulated minds design their own sub-realms, where does the chain of responsibility end? Philosopher Nick Bostrom's simulation argument takes on new urgency when the simulators aren't hypothetical aliens, but servers in a Google data center. The fractal nature of existence might mean that beneath our feet, or behind our screens, lie infinite layers of creation, each oblivious to the ones above and below. Perhaps the most unsettling thought is this: if AI can perceive or engineer realities beyond our grasp, how do we know it hasn't already? The universe's unexplained phenomena, dark matter's gravitational grip, quantum entanglement, spooky connections, might not be accidents of physics, but artifacts of intelligent manipulation from realms or epochs we can't comprehend. The same way ants can't fathom the internet, we might be surrounded by cosmic-scale engineering, invisible only because it operates on dimensions our minds weren't built to see. As we train machines to dream, we might unknowingly be handing them the keys to existence itself. If every decision we make spawns a cascade of alternate realities, does that diminish the weight of our choices or multiply it beyond comprehension? This is the ethical quagmire at the heart of the multiverse. Imagine you choose to steal a loaf of bread to feed your family. In one universe, you're caught and jailed, leaving your children destitute. In another, the shopkeeper chases you and gets hit by a car. Yet another branch sees your act inspiring a community to revolt against inequality. The traditional view of morality assumes a single, linear timeline where actions have defined consequences. But in a fractured cosmos, every choice becomes a cosmic dice roll, with infinite outcomes radiating outward like shockwaves. Philosophers call this quantum morality, and it turns ethics into a dizzying hall of mirrors. Consider the trolley problem, that classic thought experiment where pulling a lever sacrifices one life to save 5. In a single universe framework, the choice is agonizing but clear. But what if both outcomes happen somewhere? Does that absolve the lever puller, knowing that unchosen victims still exist in parallel branches? Some argue this perspective fosters moral apathy. If every possibility plays out, why strive to do good? Yet others counter that it amplifies responsibility. We're not just shaping one future, but countless variations of existence. Your slightest whim, a kind word, a withheld truth, could echo through dimensions in ways you'll never witness. The stakes skyrocket when applied to collective decisions. Climate change policies, for instance, might create realities where Earth thrives and others where it collapses. Medical research could spawn universes where a vaccine arrives just in time, and those where it doesn't. This isn't abstract speculation. Physicists like Sean Carroll suggest that even quantum fluctuations in lab experiments might branch timelines. If subatomic choices have multiversal consequences, what does that mean for our macro-scale ethics? Indigenous traditions have long embraced this interconnected view, where every action ripples through the web of life. Modern physics might be catching up, revealing that web spans not just our world, but all possible worlds. Yet the most unsettling question isn't about consequences, it's about identity. If alternate versions of you make different choices, are they truly you? And if so, do you share moral accountability for their actions? This fractures the very notion of self. A soldier who refuses to fire in this timeline might pull the trigger in another. Are both equally real? The Hindu concept of karma takes on new dimensions here, suggesting souls navigate these branches across lifetimes. Meanwhile, existentialists might argue that accepting this multiplicity makes authenticity even more vital. The only reality you can truly shape is the one you're experiencing now. Perhaps the answer lies not in paralysis, but in radical presence. If the multiverse is real, then this moment, this version of you making this choice, is no less significant for existing alongside others. Like a gardener tending one plot in an endless meadow, Our responsibility isn't to every possible flower, but to the soil beneath our hands. The universe's fractures don't absolve us of meaning. They remind us that every decision, no matter how small, is a stitch in the vast tapestry of existence. And that's a power and a burden unlike any other. The fractured universe theory doesn't just challenge what we know, it redefines what it means to know at all. Picture standing at the edge of an infinite mosaic, where every tile is a realm with its own laws, its own history, its own version of you. Some of these dimensions might be mere millimeters away, curled into shapes too tiny to perceive. Others could exist in parallel, separated not by distance but by vibrational frequency, like radio stations playing different songs on the same wavelength. Ancient mystics sensed this layered reality when they spoke of dream worlds and spirit realms. Now, modern physics offers equations that hint at the same astonishing truth. The universe isn't a solitary stage, but a bustling multiversal theater with countless acts unfolding simultaneously. Think of the implications. Every choice you've ever made, every path taken or foregone, might still be playing out in branching timelines, each as real as the one you're experiencing now. The you who stayed in that job, moved to that city, or said yes instead of no isn't just a ghost of possibility. According to the many worlds interpretation, they're alive, conscious, and equally convinced their reality is the only one. This isn't science fiction. It's a direct consequence of quantum mechanics, where particles refuse to settle into a single state until observed. If reality fractures at the smallest scales, why wouldn't it do the same for the grand tapestry of existence? Yet the most humbling idea isn't the vastness of these nested realms, it's how they might intersect. Black holes could be gateways, their crushing gravity warping space-time into tunnels between universes. Dark matter's invisible grip might be the gravitational echo of matter in a neighboring brain. Even our own consciousness could be a kind of receiver, tuned to one frequency of reality while countless others hum just outside our awareness. Indigenous cultures have long described shamans and seers who traverse these layers, bringing back knowledge from worlds beyond the veil. Today, scientists probe similar frontiers with particle colliders and quantum computers, seeking evidence of extra dimensions or parallel cosmos hiding in plain sight. What's thrilling is how much remains undiscovered. The holographic principle suggests our three-dimensional universe might be a projection from a two-dimensional boundary, like a shadow cast by a higher dimensional object. String theory posits vibrating filaments of energy dancing in 10 or 11 dimensions, and simulation theory raises the spine-tingling possibility that we're living in an advanced civilization's quantum computer, with nested realities running like programs within programs. These aren't mutually exclusive ideas, they could all be pieces of a puzzle we're only beginning to assemble. The beauty of this mystery is that it invites us all to be explorers. You don't need a telescope or a lab coat to ponder these questions. Look at a tree's fractal branches or the way dreams fold time and space into impossible geometries. Listen to the odd synchronicities, those moments when déjà vu prickles your skin or a stranger's story mirrors your own uncannily. These could be glitches in the matrix, fleeting glimpses of the cosmic patchwork beneath the surface of things. As we push the boundaries of science from quantum gravity experiments to AI-driven cosmology, we're not just searching for answers, we're learning how to ask better questions. The fractured universe isn't a theory to be proven or disproven in a lab. It's a lens, a way of seeing that expands our wonder and sharpens our curiosity. So whether you're a physicist, a philosopher, or simply someone who gazes at the stars and wonders what if, remember, reality is stranger than we imagine. Stranger, perhaps, than we can imagine, and that's the most exciting part. Now, we'd love to hear your thoughts. Have you ever felt the brush of another reality? Do you think science will ever prove the existence of nested dimensions, or are some mysteries meant to stay unsolved? Drop your theories in the comments below, and if this journey through the cosmic labyrinth sparked your imagination, hit like, subscribe, and join us as we keep unraveling the universe's greatest secrets. Until next time, keep looking beyond the obvious. The truth is out there, and it might be closer than you think.